Hello students, how are you? I hope all of you are good. In this video, I am going to start a new chapter, differential equations. And in this video, I am going to discuss totally 4 concepts. In that, the first one is definition of equation. First one is a definition of equation. And the second one is definition of differential equation. Second one is definition of differential equation. And the third one is order of a differential equation. Order of a differential equation. And fourth one is degree of a differential equation. Degree of a differential equation. And at last I am going to solve some of the examples to identifying the order and degree of the differential equations. At last I am going to consider some of the examples for determining the order and degree of the differential equations, and that examples taken from the first exercise of the chapter differential equations. So let's start the first one here. Here the first one is definition of equation. So equation means if any two expressions are related by the sign equal. If any two expressions are related by the sign equal, then that is called as one of the equation. For example, x plus 5 is one of the expression and 0 is another expression. If these two expressions are related by the sign equal, then this is called as one of the equation. Here x plus 5 is one expression and 0 is other expression. These two expressions are related by the sign equal. Therefore, this is one of the equation. So, consider one more example. So, as you know that one of the basic identity of the trigonometric functions, that is what? Sin square x plus cos square x is equals to 1. Here also the expression sin square x plus cos square x and the expression 1 related by the sign equal. Therefore, this is also one of the equation. But in this equation, trigonometric ratios are involved. Therefore, this is one of the trigonometric equation. This is one of the trigonometric equation, or you can call it trigo equation. And in the first one, x plus 5 equal to 0. So, this is one of the polynomial equation. Polynomial equation. In that, the degree of the variable x is 1. Therefore, this is a linear equation. Therefore, this is a linear equation. I hope all of you understood the definition of the equation. And what is the second one? Definition of differential equation. So, differential equation means, as you know, the trigonometric equation means an equation involving the trigonometric ratios. So, similarly, an equation which consists the derivatives, an equation which consists the derivatives is called a differential equation. In the definition is an equation which consists which consists derivatives is called a differential equation. So derivatives means, as you know that dy by dx and d square y by dx square, and third order derivative, that is what? D cube y by dx power 3. Third one is a d cube y divided by dx cube, and so on. So nth order derivative, d raised to n divides dx power n. I hope all of you understanding. And here the first one, dy by dx, is known as first order derivative, and d square y by dx square is a second order derivative, and d cube y by dx cube is a third order derivative, and this d raised to n y divided by dx raised to n is a nth order derivative. And one more thing, the first order derivative dy by dx can also be represented as y dash, or it can also be represented as y1, and the second order derivative can also be represented as y double dash or y2, and this third order derivative can also be represented as y triple dash or y3, and this nth order derivative can also be represented as y raised to n or yn. I hope all of you understood the definition of the differential equation. Differential equation means an equation which consists derivatives. It may be first order derivative, second order derivative, or third order derivative, or all of these. Then such equation is called as one of the differential equation. So let us consider one example. So I am going to consider very simple examples for the differential equations here. So let us see here. First one, dy by dx plus 2 is equals to 0. So observe this equation. In this equation, the expression dy by dx plus 2 and 0 are related by the sign equal. Therefore, first thing, this is one of the equation. And in this equation, the derivative, which is the first order derivative dy by dx is involved here. Therefore, this is one of the differential equation. So let us consider one more example. So let's see here, d square y divided by dx square power 3 minus 2 dy by dx is equals to x. So observe this equation. This equation consists of first order derivative as well as the second order derivative. Therefore, this is also one of the differential equation. So consider one more example. Suppose y triple dash power 5 minus 2y double dash power 3 plus sin x is equals to 5. So this is also one of the differential equation because second order derivative and third order derivatives are involved in this equation. Therefore, this is also one of the differential equation. So let us consider one more example. So fourth one, let y3 power 2 minus y2 plus 3y1 is equals to x. So observe this equation. In this equation, first order derivative y1 and second order derivative y2 as well as the third order derivative y3 is involved. Therefore, this is also one of the differential equation. I hope all of you understood the definition of equation and definition of differential equation. So now the next concept is order of a differential equation. See here, what is meant by order of a differential equation? Now the third concept, order of a differential equation. Order of a differential equation. See here, order of a differential equation means order of the highest order derivative. Order of the highest order derivative involved in a differential equation. Another definition, order of highest order derivative. Highest order derivative involved in a differential equation is called as order of a differential equation. Order of a differential equation means order of the highest order derivative involved in a differential equation is called as order of a differential equation. See here, we need to understand by considering some examples here. So easily I understood. So let us consider one example. Suppose dy by dx plus y is equals to x. See this differential equation. In this differential equation, only one derivative is involved. That is what dy by dx, and which is a first order derivative. First order derivative means it is a highest order derivative involved in the differential equation. So in this differential equation, only one derivative is involved. That is the first order derivative and which is the highest order. Therefore, order of this differential equation is 1. Therefore, order of this first differential equation is 1. So let us consider one more example. Second one, let d square y by dx square minus dy by dx plus y is equals to x. See this second differential equation. In this differential equation, first order derivative is involved and as well as second order derivative is involved. Among these two derivatives, the highest order derivative is a second order derivative. Therefore, order of the second differential equation is 2. Therefore, order of this second differential equation is 2. I hope all of you understanding. Let us consider the one more example. See here, third one. Y triple dash power 2 minus x y double dash power 5 plus 2y dash is equals to 0. Now observe this differential equation. In this differential equation, y dash first order derivative is involved, y double dash second order derivative is involved, and y triple dash third order derivative is also involved. But among these three, the highest order derivative is a third order derivative. Therefore, order of this third differential equation is 3. I hope all of you understanding. Let us consider one more example. Fourth one, y5 minus 3y3 plus x y1 is equals to sin x. Now observe this differential equation. In this differential equation, y1 first order derivative is involved, y3 third order derivative is involved, and as well as y5 fifth order derivatives are involved. So among these three, the highest order derivative involved in this differential equation is a fifth order derivative. Therefore, order of this fourth differential equation is 5. I hope all of you understood the concept of order of differential equation and how to determine the order of the given differential equation. So now the fourth concept, that is what? Degree of a differential equation. Next concept is degree of a differential equation. Degree of a differential equation. So what is meant by this degree of a differential equation and how we determine degree of a given differential equation? See here, to determine the degree of the differential equations, we have certain conditions. In that, the main condition is the given differential equation should be in polynomial in derivative. What is the main condition? The given differential equation must be in polynomial in derivative. Polynomial in derivative. Now the question arises when we say the given differential equation is polynomial in derivative. To say the given differential equation in polynomial in derivative, again we have certain conditions. The differential equation, if any differential equation is given, in that differential equation, the derivatives should not be attached with any other functions. To say the given differential equation is in polynomial in derivative, there exist two more conditions. The first one is the derivatives involved in the differential equation. What is the first condition? See here, barita ide nodri. Derivatives involved in given differential equation should not be attached with sine function or inverse of the sine function, or in general we say that derivative should not be attached with trigonometric function or inverse trigonometric functions or logarithmic functions or exponential functions. See here, the derivatives involved in the given differential equation should not be attached with any of the trigonometric function. For example, sine of dy by dx. See here sine of dy by dx is not a product of trigonometric function and derivative. So here derivative attached with sine function because derivative exists in place of angle. So if the given differential equation consists this term, not only this term, if the derivative attached with any other trigonometric functions, it may be cos, tan, cos, sec, cot, cosec. If these terms are exist in the differential equations, that differential equation is not in polynomial in derivative. And second one, derivative should not be attached with inverse of the trigonometric functions. For example, sine inverse of dy by dx, cos inverse of dy by dx, and all of the other. And the differential equation should not be attached with exponential function e power dy by dx, and the derivative should not be attached with the logarithmic function log of dy by dx, and the derivative should not be exist under square root. So in some cases we may eliminate the square root. In which differential equations we are able to eliminate the square root, then we can determine its degree. If we are not able to eliminate this square root, if we are not able to eliminate this square root, then the given differential equation is not in the polynomial in derivative, then its degree does not exist. So ಏನಲ್ರಿ condition square root condition ka for some cases, or for some cases, in which cases, the cases in which we are not able to eliminate the square root. And the second condition to say the given differential equation is in polynomial in derivative is the power of the derivatives involved in the differential equation should be a non-negative integer. ಏನಲ್ರಿ power of derivatives involved in the differential equation should be should be should be a non-negative integer. For example, see here, dy by dx power, this power should be a positive integer. If the power of this derivative is a negative integer or any of the numbers in p by q form, then we say that the given differential equation is not in polynomial in derivative. And the degree of the differential equations which are not in polynomial in derivative is not defined. ಏನಲ್ರಿ ಯಾವ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಪಾಲಿನಾಮಿಯಲ್ ಇನ್ ಡೆರಿವೇಟಿವ್ ದಾಗ ಇರಲ್ಲ ಅಂತ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ದ ಡಿಗ್ರಿ ಏನಿರುತ್ತ ನಾಟ್ ಡಿಫೈನ್. ವಿ ಆರ್ ನಾಟ್ ಏಬಲ್ ಟು ಐಡೆಂಟಿಫೈ ಆರ್ ಡಿಟರ್ಮಿನ್ ದ ಡಿಗ್ರಿ ಆಫ್ ಸಚ್ ಟೈಪ್ ಆಫ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ಸ್. Those differential equations which are not in polynomial in derivative. Now again one of the question arises here, if the differential equation is in polynomial in derivative, then what is its degree? If the differential equation is in polynomial in derivative, then what is its degree? So the degree of the differential equation which are in polynomial in derivative is power of highest order derivative. Power of highest order derivatives. Highest order derivatives is called as degree of the differential equation. So degree of the differential equation means if the differential equation is in polynomial in derivative, then the power of the highest order derivative involved in the differential equation is called as degree of a differential equation. I hope all of you understood. So let us consider some examples. See here, let's the first example is, suppose the differential equation is dy by dx plus 2y is equals to 3. Now observe this differential equation. In this differential equation, only one derivative is used, that is what? First order derivative dy by dx, and which is the highest order, therefore its order is 1. And now what is the degree? To determine its degree, first we need to check whether this given differential equation is in polynomial in derivative. Polynomial in derivative adana illo check madukore. See here, by observing this differential equation, we conclude this differential equation doesn't consist any term of this form. So dy by dx does not attach with Trigonometric function, inverse trigonometric functions, exponential functions, logarithmic functions are does not exist in the square root function. Therefore, first condition for the polynomial derivative is satisfied for this differential equation. And what is the second one? Power of the different derivative. Sorry, power of the derivative should be a non-negative integer. Observe here, the power of this dy by dx, power of this dy by dx is plus 1. Therefore, second condition is also satisfied. Hence, this differential equation is in polynomial derivative. And if this differential equation is polynomial in derivative, what is its degree? Degree means what? Power of the highest order derivative. Here the highest order derivative is the first order derivative and its power is 1. Therefore, degree of this differential equation is 1. I hope all of you understood. Now let us consider one more example to understand briefly. See here, let us consider the one more example for determining the degree of a differential equation. See here, y double dash power 3 minus x y dash is equals to 2. Now observe this differential equation. In this differential equation, first order derivative is involved and second order derivative is involved. Therefore, highest order is second order derivative. Therefore, its order is 2. Now, what is degree? So, observe here, the first order derivative and second order derivative does not attach with any of the trigonometric functions, any of the inverse trigonometric functions, and any of the exponential functions, and any of the logarithmic function, and does not exist under square root. It means this differential equation satisfied the first condition to say whether the given differential equation is in polynomial in derivative or not. Now check the second condition. What is the second condition? Power of the derivatives involved in the differential equation should be a positive integer. So here the power of second order derivative is plus 3 and power of the first order derivative is plus 1. Therefore, the power of the derivatives involved in this differential equation is a non-negative integer and second condition is also satisfied. It means this differential equation is polynomial in derivative. And now what is the degree? As you know that degree is power of highest order derivative. Here the highest order derivative is second order derivative and its power is 3. Therefore, degree of this second differential equation is 3. I hope all of you understood. Let us consider one more example. And suppose third one is determine the degree of the differential equation y4 power 5 minus e power y1 equal to 2. Now observe this differential equation. In this differential equation, first order derivative and the fourth order derivatives are involved. Among these two, the highest order is fourth order. Hence, order of this differential equation is 4. Now, what is the degree? See here, in this differential equation, the first order derivative is attached with which functions? Exponential functions. Attached with the exponential function. It means this third differential equation is not in polynomial derivative. So this is not in polynomial in derivative. So it means the degree of this third differential equation, is not defined. I hope all of you understood the concept of degree of a differential equation and how to determine the degree of a differential equation. So let us consider some examples for determining the order and degree of the differential equation from your first exercise of the chapter differential equations. See here. Here the question is determine order and degree. Degree is the load bracket if defined. It means degree of certain differential equations may define, may not be defined. If the differential equations are in polynomial and derivative, then its degree is defined, we can identify. If the given differential equation is not in polynomial derivative, the degree of such differential equations are not defined. That's why he has given in bracket if defined of the following differential equation. Now observe here, the first differential equation given here is d power 4 y divides dx raised to 4 plus sine of y triple dash is equals to 0. In this differential equation, third order derivative and the fourth order derivatives are involved. And among these two, the highest order derivative is the fourth order. Therefore, order of this differential equation. Therefore, order of this differential equation is 4. And for the degree, first we need to check whether this given differential equation is in polynomial in derivative or not. Observe here, the fourth order derivative used in this differential equation is not attached with any of the other function. But in the second term, the third order derivative is attached with the sine function. It means this given differential equation is not in polynomial in derivative. Hence, degree of this first differential equation is not defined. Is not defined. I hope all of you understanding. Now observe this second one. In the second one, ds by dt whole square plus d square s by dt square is equals to 0. In this differential equation, second order derivative and the first order derivatives are involved. And in the first term, the first order derivative is not attached with any of the other function. And the second order derivative is also not attached with any of the other function. And power of the first order derivative is plus 2 and power of the second order derivative is plus 1. So both the powers used here is non-negative integers. Therefore, the second differential equation is in polynomial in derivative. And here the highest order involved in this differential equation is second order. Therefore, order of this second differential equation is 2. And degree of this second differential equation, power of the second order derivative is 1. Therefore, degree is 1. I hope all of you understanding. Now the third differential equation. In this differential equation, first order derivative and the second order derivative is involved. Among these two, highest is the second order derivative. Therefore, order is 2. And degree. See here the first order derivative is involved or attached with the trigonometric function cos. Therefore, this differential equation is not in polynomial in derivative. Is not in polynomial in derivative. Therefore, degree of this third differential equation is not defined. I hope all of you understanding. Now the fourth one, this is a simple differential equation y dash plus 5y equal to 0. So only one order is used here, that is first order, therefore order is 1. And degree, observe here, this first order derivative is not attached with any of the other function, and whose power is plus 1, therefore degree is 1. So fourth one is a first order, first degree differential equation. And observe the fifth one. Here only one derivative is involved, which is a second order derivative. Hence, order of this fifth differential equation is 2. And degree. So the second order derivative involved in this differential equation is not attached with any of the other function. And power of the second derivative is a positive integer, which is 1. Therefore, degree is 1. Since because this is in polynomial in derivative. And sixth one, observe here, in this differential equation, first order derivative, second order derivative and third order derivatives are involved. Among these, highest is third order derivative. Therefore, order of this differential equation is 3. And this first order derivative, second order derivative, third order derivative are not attached with any of the other function. And power of the first order derivative is plus 4, power of second order derivative is plus 3, power of third order derivative is plus 2. Therefore, this differential equation is in polynomial in derivative. Hence, degree of this differential equation. Degree of this differential equation is power of the highest order derivative, that is 2. Therefore, degree is 2. I hope all of you understood. Now, let's start the seventh question. And the seventh question is y triple dash plus 2y double dash plus y dash is equals to 0. In this differential equation, highest order derivative is third order derivative, therefore order is 3. And its power is 1. therefore degree is 1. Degree is 1. I hope all of you understanding. Now the eighth one, in this differential equation only y dash, that is first order derivative, is involved, therefore order is 1. And degree, observe here, this first order derivative is not attached with any other function, and as well as the power of this first order derivative is plus 1, therefore degree is 1. I hope all of you understanding. Now I just go for the 11th and 12th questions. You just comment me what is order and degree of the 9th differential equation and 10th differential equation. So now the 11th one. So 11th one is d square y by dx square power 3 dy by dx power 2 sine of dy by dx plus 1 equals to 0. So in this differential equation, first order derivative and second order derivatives are involved. Among these three, the highest order is the second order derivative, therefore its order is 2. And degree, observe here, the third term sine of dy by dx, here the derivative is involved with the trigonometric function. It means this differential equation is not in polynomial in derivative, therefore degree of this differential equation is not defined. I hope all of you understanding. Now the 12th one, here the 12th one is 2x square d square by dx square minus 3 dy by dx plus y equals to 0. Observe here, in this differential equation, first order derivative and second order derivatives are involved, therefore order of this differential equation, highest order is the second order, therefore its order is 2. And degree, observe here, in this differential equation, first order derivative and second order derivatives both are not attached with any other functions, and the power of this second order derivative is 1 and power of first order derivative is also 1. So both are non-negative integers. Therefore this differential equation is in polynomial in derivative. Therefore degree of this differential equation, power of the highest order derivative 1, and hence its degree is 1. I hope all of you understood.